Thank you. It's nice to be here and see so many Pythonistas around here. So I will be talking about building geodata visualizations for the web. So what is this talk about? I will quickly introduce what is geospatial data or geodata to those of you who might not be that familiar with it. I will go through some of the technologies that you should know about it and also terminology that you can get started writing geodata apps. And then I'll go through the overview of how do you usually build applications, both the data processing part as well as some of the front-end technologies on how do you build apps. I will give some optimization tricks and also try to warn you some of the pitfalls that usually happen related to geodata. And I will show some examples on what you should consider when you want to render it on the web page. Obviously, that part is not Python, so I'll try to keep that part short, but hopefully it's interesting. I'll also go through some of the projects we have worked on that we leverage this knowledge, and I had a privilege to work with. So quick introduction on who I am. My name is Juha Suomalainen. I come from Finland. I am software architect / engineer. I still write code, and usually when I write it's Python, but I don't have that much time to write anymore. I work for a company called Wiredcraft. We are a digital product agency, and we are in Berlin, NYC, in Shanghai. And as she told me, I am located in Shanghai, so close by here. We mainly work on geocentric projects. Usually they are in the web or mobile realm and building products on top of data, but we also do some of the pure backend projects that are more engineering focused. And I have been helping build many related projects, and most recent one is that we are renewing or redoing part of the World Bank Open Data Portal. You can find out about that later. And we are all friends of open source, as I have seen many people here. So whenever we have chance, we will pick open source projects and tools. And also during this talk, I will try to recommend you mostly open source tools and services. Quickly about what motivates me, what drives me, what gets my gets my excitement up. Visualizations. I think there's just something so rewarding by working on user-facing products and getting the data in front of users and seeing how they play with it. It's kind of this kind of instant feedback when you can see their face and you can see them interacting with the user interface that you built. Second thing, slightly different, is the user experiences. Not just the visualization, but how to create user interfaces and stories around user interfaces that users like using, including using different kind of devices, supporting different kind of people with different kind of knowledge levels, and also making everything as simple to use as possible. And of course, engineering. I would have liked to put a software architecture picture, but they tend to be a bit boring, so I just put a building architecture picture because they are a bit nicer to look at. But yeah, I'm still engineer by heart, and I really enjoy building systems that are difficult problems technically and solving those. So quickly, what is geospatial data? It's basically data that is somehow tied to locations. As an example, if you have a world population by country, you can easily pick each country and their population, and then you can visualize that on a map. So basically anything you can visualize on a map is geospatial data or geodata. Choropleth, it's a bit difficult word, but it is one way to visualize data on a map. It's the way where you decide the colors of the borders based on the value in the data set. So you can user can quickly see on one glance what are the high value and low value points, and it's very easy to really compare different areas of the map. For example, here is a population of Cambodia on a state level. And as you can see very easily what are the major states and also what are the more rural areas. A little bit of our work and recent projects. As I mentioned, we are working on the open data portal for World Bank. They just opened a while ago a beta site. So if you go to beta.data.worldbank.org, you can see this site. And it's very focused on visualizing data and as well as making the data discoverable. How can users find the data they are searching for, and also exposing the sources. In the theme of open sourcing, it's always important to find the links of where does the data come from, and also how can I download it in maybe different formats so I can use it on my own applications or maybe on my research. This is another project that we did. This was for WRI on visualizing some of the flood risks around the world. And it actually combined shapes. You can see the borders around the country, as well as raster layers, which is kind of pixel-based data about how does the water flow in the nature. So you can see that there's, and then behind that there's the base map, which is kind of showing, the base map usually refers to this a kind of a standard world map that shows where are the seas and where is the land and what are the boundaries. So there's 3 layers here. And in addition to that, we added some additional information on the side, so you can really relate get more information about the selected indicators. And it's all interactive. You can click around and see things change on the user interface. This is another screenshot of a simple Choropleth from the World Bank Open Data Portal. For that project, the map-based visualization was not the focus, so it's pretty simple for now. But again, another example of a Choropleth and how it can represent data. So technologies. I'll go through some of the technologies that you should know about geospatial data, and especially what I have experience with. I'm sure these are not the only ones that you should be using, but I'll give some of my experience and maybe some of my reasoning why these technologies are good. Let me just do this. So let's start with the source formats. Usually you get the shapes from online. Like you can find websites that you can download the shapefiles, and I think most typical format is the shapefile format. It's a bit weird format actually, but I'll talk about that later. Some other formats that are used is the Esri geodatabase is used by the ArcGIS tools, I think, and KML, which is preferred by the Google ecosystem. So a bit more about shapefiles. As I mentioned, they are not typical shapefiles or typical format because it actually consists of multiple files. On the other hand, it's decoupled, but on the other hand, it's sometimes hard to manage so many files. So as an example, this is a data set about the world, of the countries of the world from natural Earth. And you can see there's 4 different files that you get. The first one is the DPF. It includes, that's the biggest one, so it includes a lot of the shape information. The PRJ is a projection, which basically means it's telling what coordinate systems it uses. It's actually optional, so I have had some bad experiences where that's missing, so you have to kind of guess what is the coordinate system that the dataset uses. For that, you should probably use a desktop system and just try to import it in different coordinates. but usually you should be able to find what is the coordinate system. The SHP is usually the core, the main entry point for this file. So if you open it in a library, you usually point it to the SHP file, and the library then tries to open the related files automatically. And SHX is, I think it was an index file, but I'm not sure. So I will be talking about web things specifically, and shapefiles are not really web-friendly. They are kind of, as I told, it consists of multiple files, and it's a binary format. So there's two important formats for the web that you should be aware of. First one is Geo Jason. It's a very basic JSON-based format. I will show you later how you can make it yourself. And it's very easy to understand, it's very easy to debug, and it's very widely supported. The second format is called Topple Jason. We usually prefer this one because it's more compact. GeoJSONs tend to get very large on a bigger data set. So if you need smaller sizes, you should use Topple Jason. It can simplify things a lot and create smaller file sizes. And especially in cases where you have shared boundaries, let's say Finland and Sweden are next to each other and they both have their own shapes. Like with GeoJSON, it represents both of those shapes as independent vectors. But topojson is actually smart enough to know that they both share the same border, so it only has one vector where they share the border. And it doesn't only save space on the data, but it also makes it simpler and more robust, so that when you simplify or when you round things up, you don't get those 1 pixel differences between countries, because that happens very easily when you start to compress things. Simple example of a GeoJSON, just to let you understand how simple it is actually, is just standard JSON where it supports multiple types. This one is called feature collection that you usually use if you have a boundary type of data. And then you have a features list, and each of those features defines the vector. So if you have a world with countries, then each country would be one feature in that list. Some of the tools that I have used in the past, and I recommend you to use too. If you just get started and want to know more about formats and play around, QGIS is very good. It's open, it's free to use, and you can import shapefiles and all kinds of formats, and you can also do many kind of transformations using that application. There's a web app called geojson.io. It's very good for debugging on, is my GeoJSON valid? You can just dump your GeoJSON on that app and it will show it on the map automatically. So it's very good for checking, is my GeoJSON valid and how does it look on the map? I will talk about Map Shaper a bit later, but it's a very good website for feature simplification. So simplification is a process where you compress the data, you make the features simpler. And Map Shaper allows you to import your data there and have a slider on how much you want to simplify it. I will show that a bit later. Mapbox.com, I think this is the only bit more proprietary technology that I'm suggesting, but I have had good experiences with using Mapbox.com. They offer both map hosting as well as good JavaScript libraries to render the visualizations on the front end. And then there's leaflet.js. Mapbox is actually built on top of that. It's the norm, the basic thing on JavaScript land on how you render map or geodata. And then there's D3. If you feel like taking a challenge, you take D3. It can do a lot of the things that Leaflet can do and more. So it's kind of lower level language, and you can do more custom things with D3. So if you have more complex use case, you probably might consider using D3. So simple approach on building a web application where you have your source in shapefiles and maybe the data comes from APIs. This is the simplest case where you have a data processor. We always write this in Python because Python is the best in data processing. So we write a simple Python application to read the shapefiles and read the data from APIs, do the translation of the formats there and also combine the data, and then output the GeoJSON and JSON files. So it's actually quite good system to produce static files as a result. That way you don't need an API on the web backend. If you have a limited dataset, that's doable. Even if you have 200 different files, it's still doable and saves you the energy of creating a separate API if the data is not real-time or dynamic. So for simple cases, it works very well to have the static step instead of an API. And the web application, that's obviously built with JavaScript nowadays. And in many cases, it can be fully static if there's no API. So it's a bunch of files and it reads static assets. And for that, we usually use React. It's a technology by Facebook to kind of allow you to have a component-based architecture on the front end, but you don't have to go that far. It's really easy to get started with just plain JavaScript nowadays. Here's the quick examples. I don't have a lot of code on my presentation, but this is the this is the biggest one. I just want to go through and explain to you how do you read shapefile, and just make you believe that it's not that difficult, and maybe understand the structure of the shapefiles a little bit. So on the top of the code, you can see that I create a shapefile reader based on the file path. I create the GeoJSON structure. As I told, it's very simple, so I just create it as a Python dictionary. That's the root of the GeoJSON structure. I pull off the field names from the shapefiles. It's a bit weird syntax to pull it up, and you have to use some list iteration, but I can get the list of field names that way. And then I loop through all the records or features on the shapefile. So shapefiles are kind of, you can think of them as an Excel spreadsheet with some added geo information in them. So I loop through all the records. I took the geo interface, which is actually the shape geometry. I take the values for the attributes, for example, the country name, or maybe they have some data about the country on the shapefile. So I take all of the values. I zip it up with the field names, so I can create a dictionary of all the attributes. And on the middle here, you can actually add any of your own data there. So this is a good place to, if you fetch data from APIs, you can combine that data into your GeoJSON structure directly. So that gives me the geometry and the properties. So I just create a GeoJSON featured Python dictionary, and I append it to the list of features. And then I have the GeoJSON as a Python dictionary, so I can just render it as a JSON file. And then it's valid GeoJSON. You can then, for example, input into the geojson.io, or you can use your own front end to use it. So that's it. That's all you need to know about rendering reading shapefiles and creating GeoJSONs. A little bit about the front end, the JavaScript application, the application that actually renders the map and overlays the layers on top of it. The general process is that you load the data, the GeoJSONs that you have. Those are usually just files, so you can just do Ajax to do that. You load the base map. Usually you use either Google Maps or OpenStreetMaps or Mapbox.com to do that. It's usually tile-based, so that you don't have to load all of the data, all of the base map at once. You can just load the tiles that you see on the screen. And usually you don't have to host them yourself. Then for Choropleth, then you style the features. You have to decide what is the color of this feature and what are the border styling for this. And for Choropleth, you use the data values to decide the colors. And then you have to create the ranges. As I showed earlier, there's on the top bottom, you can see, maybe I can show that. On the top bottom, you can see user has to have some kind of context on what does dark blue mean and what does white blue mean. So you have to create the ranges to indicate what do the different colors mean. And by our experience, it's actually good to create five or six separate colors instead of using a sliding scale, so that it makes it a bit more visually appeasing, so that you generate buckets out of the range that you have for data, and then you pick one color for each bucket. That way, there's limited amount of colors there, and it's easier for users to understand. So some of the common pitfalls on the data processing part. First of all, data encoding. It would be nice if everybody used UTF-8 and you would never have any problems, but that's rarely the case. Especially the natural Earth datasets are using different encoding, and that's one of the most popular one. And you have to be just careful on when you decode the data, when you read it from shapefiles. Be careful. The coordinate systems, it can be tricky if they are not automatically defined in the shapefiles, and sometimes you just have to try it out different systems to find the right one, but usually you'll be able to get it. And the mappings, especially if you are using country names in mappings, it can be very tricky. By the way, one thing about countries is that not all countries, even in English, can fit the ASCII character set. So I think there's like 3 countries in the world that have some weird characters in them that will break your system if you don't decode the things properly. So don't trust that it kind of looks okay for most cases, because there's a lot of countries in the world, and some of them have preferred to write their names with weird characters. I don't know why, but even in English. So try to use very standardized IDs for mappings. There's really good standardized mappings for country names, for example. Those are 2-letter and 3-letter country codes. So whenever you have a chance, use those, but do not trust them either. Like country borders change all the time, and there's wars, and then new countries are generated, and some of the data sets might be from different time periods. So be very strict about when you create the mappings, and as soon as you find a mapping that doesn't match something, try to solve it manually if nothing else can work, because it's really hard to create 100% automatical mappings. So some things you have to consider when optimizing for the web. It's all well and when you use the desktop applications to load the shapefiles. They can be hundreds of megabytes, and your processing power is enough to load it up. But for the web, it's very different. If your dataset is more than 1 megabyte, it starts to become a problem for some people. So pay attention to the size of the files and the amount of the data that you load when you load your visualizations. As I mentioned earlier, try to use topojson to save space. It has one drawback, that it doesn't have as good library support as GeoJson. But good thing is that you can switch between GeoJson and topojson freely. So we actually have in some projects used topojson to transfer the file to the browser, and then in the browser we transform it back to GeoJson so that we can use the libraries that support GeoJson. And doing the feature simplification is also important. I can actually show you a quick demo about that one. So here is one GeoJson file. This is about 111 megabytes currently, and I load it into mapshaper.org. It's a really nice tool that allows me to simplify shapes in real time. You can choose what algorithm you want to use to simplify. And then you have a slider that allows you to make it bigger. That allows you to simplify the shapes as much as you want. So if I zoom into here, you can see that once you start to simplify it too much, it starts to look like a mosaic, which is maybe you sometimes want to have this kind of look. And depending on your needs, you can simplify it as much as you want. And this is mainly good for testing out different kind of shaping simplification levels and seeing how big files result on it. It actually shows some of the potential problem areas for your shapes. So when you simplify too much, it becomes very non-accurate sometimes. So you can use this tool to play around and see how much you can simplify the world. Unfortunately, this is not Python technology. So if there's any people excited to work on simplification algorithms, I recommend create an open source project with good documentation and implement this in Python. This is actually a Node.js project, I think, and they also have their code in GitHub. So we actually used the command line tool to post-process the files using this tool. But it's anyway good to visualize the simplification process. So, a few words about optimizing the Choropleth itself on the web front end. I think one thing that can become really not user-friendly and can make it look a little bit crappy if the borders are too strict or the borders are not styled correctly. As I told, you will often get problems with the borders of the countries because they share the same border, and if you simplify too much, you might have those 1 pixel differences in the shapes, so that will look very ugly. So most of the JavaScript libraries allow you to style the borders, so you can actually make them semi-transparent or make them a bit bigger so that it hides some of the imperfections of the shapes themselves. Make it interactive. Some of the cool things about the modern web technologies is that it allows you to abstract a lot of the difficult engineering problems. For example, data binding is nowadays really easy with the modern frameworks. So you can create interactive interfaces where you click one part of the interface and it highlights it in different parts of the interface. And this is not only cool, but users actually use your application more if you create more interactions. If you have more things to click around or scroll around and pop-up animations or pop-up things that they can try out, it will encourage them to discover more about your application. So it's not just good for demos, but people actually use it more if you have more interactions. And try different color schemes. It's not always easy to come up with a good color scheme, and it's actually pretty important to create a good visual style, is that you pick the colors right. And usually it's the simpler the better. Don't pick 5 different colors for the Choropleth because it will just look like a mess, unless that's what you are aiming for, but hopefully not. So if you're getting excited about building visualizations, here's some links about where you can find the data. Natural Earth is one source where you can download shapefiles of the different countries and I believe they also have states of countries. And GDAO. No, I think I have a typo there. It should be gadm.org. They have a good set of data also, and those are the 2 places I usually go to check some shapefiles if I need some for visualizations. If you need some data to play with, especially on country level, World Bank Open Data API is very good. That's the link to their documentation. So it's very easy to pull pull data for different countries for different years from their API, and it's very good for just trying out stuff and creating, while you are learning to develop the visualizations, just use the data from there. They support also JSON on their API. Just to wrap up some of the resources and kind of summarize what you should be comfortable with. The formats I mentioned, Shapefiles as a source formats, Geo Jason and Topple Jason to actually expose it to the web. Some of the Python packages I usually use are pyshp. That's the one I used on the code example I showed earlier. Geo Jason package, and there's actually not that mature topojson library in Python. At least I haven't found so far. So again, if you want a good side project and want to learn more about this, write a good topojson library. Some of the websites or services that I use is the mapbox.com. One good thing about them is that they have really good developer documentation. If you want to create a Choropleth, they have example of how you create Choropleth and very well documented code. Mapshaper.org, go there to simplify your shapes and play around with the GeoJSON. And geojson.io is a website that you can use. I can actually show it right away. Oh, I think I didn't have it open. Anyway, you can just copy-paste your GeoJSON there, and it will immediately show it on the website. Of the desktop tools, I recommend QGIS. It's good to just open up, and it can also do really powerful shapefile processing. If you want to do stuff like, let's say you have all the states of the world in one shapefile, and you want to combine that to be actually all the countries, so you can actually merge shapes based on attributes very easily on the tool. And if you want to read more about these things, we have a blog in our website that we write about our projects and how we approach our problems, and a little bit more about what we do. One thing to remember, it's very hard to remember that as an engineer that users only care what they see. They don't care if you have a good API or elegant solution on the back end if it doesn't show up somehow on the user-facing parts of the project. So remember interactivity, make things clickable, make things hoverable, and try to encourage people to use your website by that. Put attention on colors and styling. Ask your friends if you don't know how to do it, but it's important for users to feel comfortable using your website. Usability with different kind of people. Not all the people use desktops, so try out your things on a mobile, and they have so many tools nowadays to create responsive websites, so there's not really reason to not support mobile devices. And talk to the users, especially if you have any kind of commercial product. Talk to the users, they know best. You get best feedback by just talking directly to the users and putting something in front of them as soon as possible. It's something we try to encourage internally as much as possible, is to have a fast iteration and talk to users and get feedback. I will show you a quick example. I created this yesterday. It's a map of Pythonic score by the different states or provinces in Taiwan. Here you can see that I created a score of my own and laid it on a Choropleth and adjusted the colors accordingly. How did I get the data? There's some wise guy said that 57.144 of all the statistics are made up, so I decided I might as well belong to those people. So this is how I created my scoring system. I just check the name of the province, and if it's close to the word of Taipei, then I give it higher score. That way I managed to get Taipei high up on the list because I know there's many people from Taipei here. And then I just average it out, and that's how I created the score. I can actually show you a bit more about the code. So this is the clip that I showed earlier. There is the give score function that I run to create the Pythonic score, and then I append it to the properties, attribute called Pythonic score. And here was the function that I used to. I took the name _2 attribute from the shapefile. That was the name of the province. And then I just compare it to the world PyTaipei by just taking the ASCII difference and then taking the best match out of all the characters and doing some adjustments to make it better and averaging out in the end. So I will show quickly about the front-end part. It's really not that complicated. I think this was based on Mapbox tutorial. So I hope you can see that. As I mentioned earlier, you just have to load the feature at first. So I point to the URL. It's on the same folder, so it's called test3.geojson. And this loads it up using the Mapbox library. And then one cool thing is about you can define functions for each feature. So when each of the states load up, I can define functions on different events. I didn't actually use it on this demo, but you can easily have a function on when your mouse hovers on top of it, you can change the style of it. And you can also have a click handler very easily on showing the tooltip or whatever. I have one function to add the legend. So legend is the thing that is on the bottom right corner that shows the different ranges. And I manually defined the ranges based on the scoring system that I had. You could automatically generate this if it's purely linear, but for the simplicity on the example, I just manually defined the ranges. And then I just loop through all the ranges and append HTML to the legend. So it's very low level and very simple to get started with. So the core logic for the Choropleth is to define the color for each feature. And I did it by just creating different ranges on a manually defined colors for each of the ranges. Again, it's actually not that easy to automatically create a good scaling for the colors. So I think I used Photoshop to pick up these 6 colors, and it's not that much work. And usually it's easier to get a visually pleasing Choropleth by manually picking them up. And so how do I use that function? As I mentioned, for each of the ranges, I do for each of the features, we call the get style, and that gives the feature or the shape, for example, the province of Taiwan. And then I define the styles for it, and including the fill color, and the fill color comes from the function. And I pass the Pythonic score to that fill color. And since it's a Geo Jason, it's just simple dictionary of feature.properties.python score. So it's kind of, since everything is JSON based, it's very easy to understand on the front end and very easy to get started with. I can actually show it. Yeah, I think that's enough. I can see some hungry faces here, and I also want to go eating soon. I don't want to keep you too long time. If you have any questions, we can have some right now. And yeah, any questions?
Hello, I'm interested that you mentioned that you process your raw data to GeoJSON or other formats and then pass it to the front end, right?
Yes.
So I was wondering, do you, in some cases, persist the processed GeoJSON or other Geo-Data?
Can you persist what?
Persist the processed data.
So in this case, I included the data and the shapes all in GeoJSON files. We have a lot of projects where we actually use APIs separately for the data itself. So we actually might, in those cases, persist the data in the database. But on simple cases, we try to keep it all in static files if possible. That saves a lot of headache. But it's definitely possible to have a different path for the data and the shapes, and then in the front end combine them again. I hope that answers the question. Anyone else? There we go.
Hi, I have a question. Is possible to draw a map on the front end and transfer to the back end for user to draw their house, something like that?
You mean zooming?
Yes, zooming in. If you use a world map and
Yes.
try to draw something in the front end,
Yep.
and send back to the back end, is this kind of web application?
So these applications do everything on the front end.
Yes.
So in these cases, it's done all on the front end. Go ahead.
Yes. In your case, is show the data from back end is possible to user can draw something in the front end and send back to the back end.
Okay. I think we have done something similar in the previous times. I think it would be an interesting project if I had one. I haven't worked on the project like that, but this kind of two-way communication and letting users actually create maps. We have done some similar things by giving the user a CSV. They can copy from Excel or something, and then they can create their own visualizations by just copying things to a spreadsheet and sending it to backend, and then it processes it up into a visualization. That's a bit similar to what you say, but we haven't done a project where you can directly on the map interact with it. But that's certainly interesting problem to solve. Anyone else?
Does your work involve any spatial operation like spatial intercept or overlapping type of the analysis?
On some cases, yes, but usually we have done, at least on previous project I have worked with, we have done map-based, country-based and state-based visualizations where we get the pre-processed data sets. So we didn't actually create a lot of the shapes ourselves. We just used the open source shapes. So we avoided going to solve those problems because they can become very difficult. We have solved few of those on special cases with manually by using the QGIS software, but we haven't had a project where we automatically do this kind of complex solutions on the maps themselves. There's one more.
Hello. In your talks, I only seen 2-dimension map information visualized. So do you have you know any other 3-dimension transfer tool on your
we have kind of
job like that?
I think closest we have got into a 3-dimensional, I can call it 2.5 dimensionals, is that we added a slider based on ears. So you can play different ears and it animates the changes across the ears. but I haven't been personally involved in creating 3D visualizations. I think I would surely be excited to be in one, but it's sometimes challenging to make it simple enough for web technologies and also for typical users to make it intuitive at the same time.
No, I mean a lot of GIS data like point clouds or bin building information like that. Could you visualize that information on some suggested tool?
You mean, in this case I talked about shapes, but you might have points or something else. Is that what you mean?
I mean LiDAR data.
Say again?
LiDAR data.
Like
Point cloud.
PyCon, okay. I don't actually have that much experience on that side, so I can't really answer that one with...
Thank you.
Yeah, sorry about that. Anyone more? Okay, you can reach me in Twitter. It's got Juha Finn, since I'm from Finland. And thank you so much. And thank you for the volunteers to organize this conference. It is very good.